Okay, so for this section, we're going to talk about inequalities involving quadratic functions. So I always like to break down, you know, the title. So inequalities is basically, your alligator symbols, right? So that's your less than, equal to, greater than, equal to. And then quadratic functions is what we've just been talking about, which is the ax squared plus bx plus c. Let me rewrite that there. Right? Those are quadratic functions or parabolas. Okay, so those are in that form. Anyway, so the biggest problem about this is understanding the notation um, and writing our solution based off of that notation. So let's say we have this function. This is our f of x. Okay, this graph here is our f of x. And um, So if you understand this part, then the problems are going to be easy. Okay. So here we have f of x is less than or equal to 0. Okay, so here we have f of x is less than or equal to 0. F of x is greater than 0, and f of x is equal to 0. So, um, so there's a couple ways to look at this. When we were dealing with piecewise defined functions, when we saw the the inequality. We talked about from the left and the right, right? But in this case, when it deals with the quadratic like this is talking about above or below or at, okay? So when you have um, less than or equal to, this is talking about below, okay? When you have greater than, that means it's talking about above. All right. And then at equals, that means it's talking about at that, at that value. Okay. So one analogy is someone swimming. So this person is, say this is the swimming pool, right? This line, black line here is the floor. Okay. So the person is above the pool from 0 to 1. Then it goes into the pool from 1 to 2, then it gets out of the pool from 2 on. So if you think about it that way, it makes it easier to read or understand what this is saying. Okay, so for example, for this one, f of x is less than or equal to 0. It's asking where is the guy or the person below or in the pool? Well, if you look at our graph, the person is in the pool in this area. Okay, so that means from 1 to 2. Now we have to be careful because it says less than or equal to. So that means then we need to also include the endpoints. Okay, so in this case, I just write it in interval notation and I write from 1 to 2, and that's it. Okay, the swimmer is in the pool from 1 to 2. Okay. Okay, so I changed this here. I need to put that back to greater than. Okay, so in this case, for the second one, we want greater than 0, or that means when the person is above the pool. And so that's going to be from 0 to 1, and then union, or you can put a comma there, doesn't matter to me. Then from 2 on. Okay. And we're going to put infinity there because it's an arrow going in the right direction. Okay, so it goes on forever. So in this case, we won't include the endpoints because we don't have an equal sign. Okay, so if we had an equal sign, then we would include the endpoints except for the infinity part. All right, And then for the last one here, f of x is equal to 0 is asking at particular values or particular x points. So remember, f of x, another way to write f of x is y is equal to 0. So this is the same thing, okay? So it's asking when y is equal to 0, what are the x values? So in this case, also, this is a what? A horizontal line, right? This is also a horizontal line. So if we draw a horizontal line right above the x-axis, then it's going to cross at three particular points, and that is this point at 0, 1, and 2. Okay? So again, it's asking when y is equal to 0, what are the x values? So it's saying if we draw a line on the x-axis, where is it crossing? What particular x values is that y crossing? Okay? So let me get rid of all that. So in this case, again, it's going to be at 0, 1, and 2. So our answer is going to be 0, 1, and 2. All right, so this is going to be a three-step problem. All right, so step number one is we need to address the inequality. Okay, so the inequality is telling us less than or equal to. So that means below, right? We need to find out where is the graph below the x-axis. Step number two is we need to sketch the graph to understand where is it below. And then step number three, we need to write down our answer. Okay? So how do we find out, you know, where is it below? Well, first, what we need to do is we need to factor. So I'm going to factor here. So we have x squared minus 4x plus 12. Okay? And I'm going to set that equal to 0. So I'm going to ignore the equality for right now because I'm just factoring. So the factors here are going to be, I'm sorry, this is, let me rewrite that because this totally changes the problem. All right, so it's not a positive 12, but it's a negative 12. So let me change that there. So this is a negative 12, and this is a negative 12. Okay, so when we factor this, we're going to get x minus 6, and then x plus 2 equals 0. And then so in this case, we get x equals positive 6 and negative 2. Okay, so what are these? These are going to be our, excuse me, these are our x-intercepts. All right, so these are our x-intercepts. And let's do a sketch. So we know this is a parabola, right? Our quadratic function. And we also know that the leading term is positive. So that means that we have a happy parabola. Okay, so let's do our graph here. Okay, again, we're just doing a sketch. So the key part of this sketch is our x-intercepts. So we have them at negative 2, and we have it at 6. 1, 2, 3, 4, 5, 6. Okay, so those are their key points here. And as I just mentioned, this is a happy parabola because the leading term is positive. So that means I'm just going to draw my parabola open. So, all right. And again, I'm just doing a sketch. I don't know where it is, where the vertex is. It doesn't matter right now. Okay. All I want is a sketch of this. Now we have all the information that we need. And now we can answer the question. So it's saying, where is it below or at 0 or equal to 0? Less than or equal to 0. So we look at this here, okay? The swimmer is under the water between what? -2 and 6. All right? And then it's less than or equal to, so that means we need to include the endpoints. And that's it. It's that simple. All right? But again, this problem is misalong. So here for our answer, it's going to be between -2 and +6. So the key to this question is graphing this, right? Making a sketch of it and then understanding what the inequality is asking. All right, so the first thing we need to do here is we need to move all our terms to the left because we need the right side to equal 0. So we're gonna subtract x on both sides, subtract 10 on both sides. So again, we're just gonna move these terms here, and we're gonna get 2x squared minus x plus minus 10, which is greater than 0. Okay. Then we're gonna take that trinomial and we're gonna set it equal to 0 and then factor it. All right. So in order to factor it, we're going to use the slide method. So we're going to take the 2, bring it to the back. We have x squared minus x minus 20 equals 0. Then we factor. And that factor is going to be x minus 5, x plus 5. I'm sorry, x minus 5 and x plus 4 equals 0. Now we need to be careful because a lot of students will say, oh, I got my factors and I'm good. But since we multiply by 2, we have to divide by 2. So please remember that. That is a common thing that students forget. So we get 2x minus 5. So again, I take that 2 here. Since I can't reduce it, I bring it to the front. And this one I can reduce, so that will just be x plus 2. So those are our factors. Okay. So then we solve for x. So the first one, we're going to get x is equal to 5 over 2. And the second one, we're going to get x is equal to -2, right? So add 5 on both sides, divide by 2, and subtract -2 on both sides, you get -2. Okay. All right, so these are what? These are our x-intercepts, right? Those are our x-intercepts, and that's important. So let's go ahead and draw our graph now. Okay, so we have -2, and then we have 5 over 2 is 2.5. So 1, 2, 3, so it's somewhere here. So let's go ahead and plot those. So we got -2, which is right here, and then we have 1, 2.5, or 5 over 2 is right there. Okay, and then we look at our parabola. Again, we have a positive leading term, so that means we're going to have a parabola that's facing up, all right, or a happy parabola. Okay. All right, so now we want what? We want it when the graph is greater than 0. So that means we want it above. So in this case, it is above, over here, and over here. Okay, so that's where the graph is above. So in this case, then our answer is going to be -infinity to -2 union 2.5 or 5 over 2 to positive infinity. Okay. So union just means and I want this. Okay. So, and then we don't include the endpoints because it says greater than. If it's a greater than equal to, then we would include -2 and 5 over 2.